So right now, there's a visitor in our solar system, an object that has traveled from interstellar space, and it seems to be breaking all the rules. This is the curious case of Comet 3I/Atlas. All right, let's dive in. This whole story kicked off when an object showed up in our cosmic backyard, an object that, as we'd soon find out, was unlike anything we had ever seen before. So picture this. It's early July 2025. The Atlas Survey Telescope down in Chile flags a new object, and right away, scientists knew they were looking at something special. This was only our third known interstellar visitor. But here's the thing. As the data started pouring in, it became crystal clear this wasn't just another interstellar comet. Nope. This was an object that was about to challenge our understanding of what's even possible. So, what's the big deal? What exactly makes this thing so different? Well, for starters, just look at the raw numbers. Compared to our other interstellar guests, Oumuamua and Borisov, 3I Atlas is moving at a blistering 58 kilometers per second. And its age? Scientists estimate it's somewhere between 3 and 11 billion years old. So this isn't just a visitor, it's a truly ancient relic from another star system. And this, my friends, is where the mystery really deepens. The way this comet was behaving, well, it started to raise some serious questions. You see, at first, 3I Atlas was so incredibly bright that astronomers thought, wow, this thing must be huge. The initial guess was maybe 10 kilometers in diameter. And, an object that large from interstellar space would be an absolutely mind-blowing find.
But then, we pointed the Hubble Space Telescope at it, and what it saw? Well, it completely flipped the script.
Yeah, Hubble's new measurements were a total shocker. The nucleus, the actual solid core of the comet, is somewhere between 440 meters and 5.6 kilometers across, much smaller than we first thought. The original estimate was thrown off by the unbelievably bright cloud of dust and gas surrounding it, what we call its coma. So, this of course leads to the next big question, right? If the comet's core is actually on the smaller side, then why on earth is it shining so brightly? And the puzzle just kept getting weirder. Get this. When NASA's TESS satellite tracked the comet, it expected its brightness to go up by a factor of, say, 1.5 as it got closer to the sun. Normal stuff. Instead, its brightness surged by a factor of 5. A truly shocking discovery. So what does that mean? Well, the big takeaway is that this comet is way more active than it has any right to be. The data suggests it started outgassing, releasing its gas and dust, when it was still 6 astronomical units from the sun. That is way out there, near the limit of where comets usually wake up. It kind of hints that it might be releasing something far more volatile than just water ice, something that turns into gas at much colder temperatures. And believe it or not, the comet's weirdness doesn't just stop with its behavior. Its very chemical and physical signature, well, that's what really sets it apart from almost everything else we've ever seen. Observations from the Gemini South telescope were just staggering. They revealed it was releasing enormous amounts of cyanide, about 800 sectillion molecules every single second. That's an 8 with 23 zeros after it. But more importantly, it was found to be carbon chain depleted, meaning it's missing certain kinds of carbon molecules. And here's the kicker. Our last interstellar visitor, Borisov, had that exact same trait. It really makes you wonder if comets from other star systems are just fundamentally different from our own. Okay, so to get our heads around this next clue, we need to quickly talk about a technique called polarimetry. Now, it sounds complicated, but the basic idea is pretty simple. It's a way of studying an object's surface by looking at how it scatters light. You can kind of think of it like using polarized sunglasses to cut through glare so you can see details you couldn't see before. And when scientists used polarimetry on 3I Atlas, they found something that honestly must have made them stop in their tracks. They described its light signature as having an exceptionally deep and narrow negative polarization branch. Now that might just sound like a bunch of scientific jargon, but what it means is absolutely profound. Because what it means is that 3I/Atlas scatters light in a way that has never been seen before. Not in any other comet, not in any asteroid in our solar system, not one. Even Borisov, the other interstellar comet, showed the complete opposite, positive polarization. This suggests the dust grains in its coma might have a totally alien structure or composition, challenging our very models of how comets are even made. So, when you have this many strange, unique properties all stacking up one after another, well, it was probably only a matter of time before the conversation turned to a more
controversial explanation. And that's exactly what happened. Harvard astrophysicist Avi Loeb and his collaborators published a paper with that very direct title. They basically explored whether all the comet's unusual characteristics, especially that initial massive perceived size, could maybe, just maybe, point toward an artificial origin.
However, the broader scientific community was very quick to pump the brakes. Critics point out that Loeb's argument was built on that early and now outdated 10-kilometer size estimate. Plus, the comet's trajectory and its path through the solar system can be perfectly explained by natural gravity. No need for any kind of engineered course corrections. For many, it's a fascinating idea, but one that maybe jumped to conclusions before all the data was in. So where does that leave us? What happens now? Well, the investigation into this incredible object is far from over. In fact, you could say the most exciting part is just getting started.
On October 30th, the comet will reach perihelion, its closest point to the Sun. Now, we won't be able to see it right then, but it will pop back into view for us to observe in early December. And when it does, an absolute army of telescopes, including Hubble and the James Webb Space Telescope, will be waiting to analyze it in more detail than ever before. Which leaves us right back here with the ultimate question. Is 3I Atlas a truly unique ancient relic from the dawn of another solar system, giving us a peek into a completely different way planets might form? Or is it something more? Whatever the answer turns out to be, its journey through our cosmic neighborhood is guaranteed to teach us something new about the incredible diversity of the universe. The only question is, what secrets does it still have left to reveal?
Welcome to The Debate. Our focus today is on 3I Atlas, the third confirmed interstellar object discovered blazing across our solar system. Identified back in early July 2025, this visitor from beyond is moving at a truly astounding 58 kilometers per second, and, well, it carries an estimated age of somewhere between 3 and 11 billion years. Its appearance immediately triggered, really, unprecedented global observation using the best instruments we have, Hubble, James Webb, you name it. But beyond the sheer excitement of just tracking an interstellar body, 3I Atlas introduced a, let's say, controversial hypothesis that challenged the very definition of a natural cosmic object. So the central question we need to grapple with is this: does the available evidence concerning 3I Atlas compel serious scientific consideration of the possibility that the object is, quote, alien technology rather than a purely natural comet? Now, I maintain that the initial, frankly, profound statistical anomalies and the unique physical characteristics revealed by later data, especially its extreme activity and unprecedented light scattering, they mandate that we keep the technological hypothesis on the table for rigorous testing.
And I take the opposing view. While the initial measurements were certainly attention-grabbing, yes, the continued and, frankly, rapid accumulation of refined, high-fidelity data overwhelmingly supports a natural, albeit highly exotic, cometary explanation. I'm going to argue that the technological claims rely heavily on interpretations rooted in premature or worse, already superseded measurements. This makes invoking extraordinary technology, well, unnecessary and scientifically premature, in my view.
Right. But the scientific controversy didn't just emerge from a vacuum, did it? It stemmed directly from the initial, quite legitimate, scientific estimates of the object's physical scale. Early measurements of 3I Atlas estimated its radius to be astonishingly large, something like 10 kilometers. Now, if that size held true, based on our current understanding, our census of material in interstellar space, an object of that mass and size entering our solar system would be an extremely rare occurrence. I mean, statistically improbable to the point of being almost absurd. This profound statistical anomaly alone, raised by esteemed researchers like Avi Loeb, was the justification for exploring alternatives. We can't simply dismiss data that fundamentally contradicts our standard expectations just because, it makes us uncomfortable. The question, is the interstellar object 3A Atlas alien technology, was, I think, a necessary response to the data available at that moment.
Okay, but that initial premise, the very anchor of the technological argument, was almost immediately undermined by better measurements. The flaw in the original 10-kilometer estimate was one of, let's be honest, fundamental scientific process. It assumed the reflectivity was solely from the solid nucleus, entirely neglecting the significant diffuse coma of gas and dust already surrounding the object. Within weeks, Hubble observations dramatically refined that size. When the comet was, 446 million kilometers away, the confirmed nucleus size shrank to somewhere between 440 meters and a maximum of 5.6 kilometers in diameter. This correction entirely negates the statistical argument of extreme rarity purely on size. The technological speculation therefore really rests on incomplete and, frankly, quickly obsolete data. Rigorous science requires patience. We have to allow the data to stabilize. Jumping to alien engineering before the dust settles on basic physical parameters is just not rigorous inquiry.
I challenge that premise, though, the idea that we had the luxury of patience. When you're presented with a unique, fast-moving interstellar object, a literal target of opportunity, scientists have a finite window, right? A limited time to gather data before it moves out of range or potentially breaks up. The initial calculation of rarity based on a 10-kilometer radius was a legitimate anomaly, and rapid, innovative theorizing was, I'd argue, essential. If we wait for perfect data, we risk missing the chance to test hypotheses against the phenomenon while it's actually observable. The exploration of unconventional origins wasn't just an intellectual exercise. It was a necessary, rapid scientific response to unexpected data.
The necessity argument feels a bit weak when we look at the subsequent timeline regarding, let's call it, data hygiene. I find it difficult to reconcile the argument for rigorous testing with the fact that the initial, outdated estimate continued to be cited as the foundational argument for the technological thesis long after it was publicly corrected. I mean, the Hubble press release on August 7th stated the maximum size was 5.6 kilometers. At that point, the fundamental premise of extreme rarity just vanished. Yet we saw the older 10-kilometer estimate still being used in prominent public arguments as late as mid-August. This is the core issue for me. If the foundational premise is demonstrably false, according to verified, published data, scientific responsibility dictates the hypothesis must be abandoned or radically restructured, not just clinging to the convenient anomaly.
That's a fair point regarding data hygiene. I'll grant you that. But let's shift focus for a moment from the nucleus size, which, let's face it, is inherently hard to measure because of the coma, to the dynamics, the object's behavior, its energy output.
Precisely. And beyond size, a common indicator cited for technological intervention is the proposed non-gravitational acceleration. The argument often suggests 3 Atlas made engineered maneuvers maybe to achieve some non-coincidental flyby of Venus, Mars, and Jupiter, but critics, including AKMI Sonal Hawk, have definitively rebutted this. The most recent trajectory data is explained far better with natural dynamics, specifically cometary outgassing. So why invoke a complex technological explanation when natural orbital mechanics supplemented with known cometary physics account for the motion? If the motion is naturally explained, the technological argument becomes superfluous. It violates Occam's razor, the basic scientific principle of parsimony.
Okay, but I come at the non-gravitational dynamics from a different angle entirely. While yes, natural dynamics might explain the gross trajectory, the scale and the location of the non-gravitational acceleration suggest an extreme level of activity, far exceeding what we'd expect from a typical comet. We are talking about anomalous energy output here. Consider the test data, spanning May 7th to June 2nd. During this period, 3 Atlas was way out at 6 AU.
Right, and just for context, 6 AU, astronomical units, that's 6 times the distance from the Earth to the Sun. That puts the object well past the typical water-ice sublimation limit. So the common engine for cometary activity, water turning into gas, should be essentially dormant out there.
Exactly. And given that distance, the calculated expected increase in brightness, or flux, due to orbital proximity alone was just a factor of 1.5. Yet the test data showed a shocking surge. The object's brightness increased by a factor of 5. That means 3 Atlas was 3.5 times brighter than simple orbital mechanics could account for. This confirms extreme, unexpected activity happening very, very far from the Sun. Now, the only way to explain this naturally is by invoking hypervolatile compounds. highly sensitive frozen gases like nitrogen, carbon monoxide, or maybe even hydrogen that sublimate at extremely low temperatures. So this points to two possibilities, right? Either 3 Atlas is composed almost entirely of these hypervolatiles, which is unusual in itself, or that extreme energy output suggests a highly unusual internal structure or perhaps some kind of energy source. When an object is dumping that much energy into space from such a distance, the question of whether that output is controlled or merely chaotic becomes, I think, scientifically justifiable. This energy output isn't easily dismissed as just normal cometary dynamics. It's really at the very edge of what we currently understand about comets.
But this activity, while yes, extreme, is fundamentally a matter of composition, not design. The presence of hypervolatiles is exactly what we should expect from an object originating in the extremely cold environment of another star system's outer edge, an environment likely far colder than our own Oort cloud. It's an environmental fingerprint, essentially. When these exotic compounds sublimate, the resulting non-gravitational force is enormous. So while the factor of 5 increase is striking, it simply means we're observing a comet dominated by these exotic ices. The physics still work, they just require different input compounds. It defines a new category of interstellar comet, not necessarily a technological probe.
That's a compelling argument for a new class of comet, I agree. But let's move to a feature that is arguably even more unique than its activity, the polarization signature. Forget size and trajectory for a moment and look at the physical properties of its surface material, revealed by these advanced light scattering techniques.
Okay, you're talking about polarimetry here, which measures how light scatters after hitting the coma and the surface dust. It gives us a profile, basically, of the particle sizes and the porosity of the material.
Precisely, and the first ever polarimetric observations of 3I Atlas revealed an exceptionally deep and narrow negative polarization branch. Now, this is crucial because positive polarization is typical for dust and ice in our solar system's comets. Even the other major interstellar visitor, Borisov, showed positive polarization. Negative polarization, in contrast, strongly suggests that dust particles are extremely dark, large, and highly porous. In essence, the surface is very, very fluffy or maybe aggregated. This behavior sets 3I Atlas apart from any other comet or asteroid we have ever seen. It defies the standard solar system model. So when an object exhibits a physical property, a light scattering pattern, that is genuinely unprecedented among known natural bodies, how quickly can we really afford to dismiss unconventional origins? This forces us to consider that the construction itself might be fundamentally different from the naturally formed objects we've cataloged so far.
I agree the polarization signature is unique and certainly demands classification, but I reject the leap straight to technology. Intellectual charity requires us first to exhaust all possible natural explanations. And look, the polarization isn't entirely without precedent in the solar system. The negative polarization branch seen in 3 Atlas is actually shared by certain families of trans-Neptunian objects, TNOs, in centaurs, objects that formed way out in the outer, colder reaches of our own system. These objects often show that highly porous, sort of fluffy structure that creates the negative polarization signature. So this suggests a natural continuum. 3 Atlas simply represents the extreme end of cold formation bodies, a category that already exists, albeit maybe not perfectly matching. Furthermore, let's consider the Gemini South Telescope observations, which give us a compositional fingerprint. They classify 3 IAALS as carbon chain depleted, meaning it produces a low ratio of C2 molecules relative to CN molecules, less than 0.09 C2 for every CN.
And why does that specific ratio matter so much?
Well, the C2CN ratio is essential because it's a tracer of the formation environment. A depletion like this suggests the object formed in a very cold, primitive region far from the heat of its parent star. Critically, this exact carbon chain depleted feature is shared by Borisov, the other interstellar object. This points toward a consistent shared chemical pattern in these interstellar visitors, a different chemical taxonomy reflecting different stellar nursery formation conditions. It seems far more rigorous to define a new natural class of hypervolatile, carbon-depleted, fluffy-surfaced interstellar comets than to jump immediately to the conclusion that this is an engineered construct merely because it's unique to our, let's face it, limited local experience.
But to define a new natural class, we really need consistency. And while the carbon chain depletion, yes, connects 3I Atlas and Borisov, the polarization completely separates them. Borisov exhibited positive polarization, typical cometary behavior. 3I Atlas showed this deep, narrow, negative branch. That means that two objects, both interstellar, both carbon-depleted, have wildly different surface textures and scattering properties. That lack of uniformity between them kind of undermines the idea of a single, coherent, natural class of interstellar objects, doesn't it? And perhaps strengthens the case for this specific object, Atlas, being a significant outlier.
But couldn't that lack of uniformity simply reflect the enormous diversity of environments across the galaxy? We've seen two objects, really just two well-studied ones, and already they demonstrate a vast range of possible stellar nurseries and evolutionary paths. To me, that reinforces the natural explanation, that these objects are basically geological fragments ejected from countless different stellar systems, all unique in their own way. If they were probes designed by a single civilization, you might expect more consistency in materials or dynamics, wouldn't you? Instead, what we see looks like geological complexity.
Look, solving the mystery of 3A Atlas requires finding patterns in just mountains of data. And sometimes the only way to find those patterns is by testing ideas that lie outside the current paradigm. The sheer confluence of its features, from its initial statistical improbability based on size to its unexpected massive factor of 5 activity far from the sun and its unprecedented negative polarization signature, all this suggests that the window for exploring unconventional, maybe technological origins shouldn't be closed prematurely. If we fail to test the full range of possibilities against the evidence, we risk discarding the true nature of this remarkable visitor.
And I'd argue that understanding the limitations and the rapid evolution of a data is paramount to good science. The initial compelling arguments for a technological origin were based on size estimates that proved, frankly, wildly inaccurate within weeks. The current verified evidence, including refined trajectory data that fits non-gravitational outgassing and compositional classifications like the carbon chain depletion shared with Borisov, point strongly towards 3A Atlas being a fascinating, hyperactive, but ultimately natural interstellar comet. The enduring lesson here, I think, is the danger of rushing to conclusion based on preliminary measurements and maybe confusing statistical rarity with designed purpose.
The research surrounding 3 Atlas is certainly moving almost as fast as the object itself, constantly refining our understanding. We still anticipate critical analysis from missions including SOHO, SphereX, and MAVEN, which should add more pieces to the puzzle.
Absolutely. And those future observations will undoubtedly provide the crucial data needed to hopefully solidify its classification one way or the other.
Indeed. And I think the value of considering both the conventional explanation that it's an extremely unique comet and the unconventional perspective that it might be something else entirely allows for a richer and ultimately deeper understanding of what this elusive visitor may truly represent in the grand taxonomy of objects in space.